Let's say you decide to build a custom bicycle from scratch. You figure it will take a single weekend and cost about $300. But by Sunday night, you've spent $600, and you have half a bicycle completely scattered across your garage. Our brains have a funny way of ignoring reality when we're excited. We focus on the best-case scenario and completely block out the possibility of missing parts, shipping delays, or simple mistakes. Best-case thinking is fine for a weekend hobby, but it doesn't work in a professional setting. If you need a bank, a boss, or an investor to give you money, they will not fund your hopeful wishes. They need objective data. To get that funding and actually finish what you start, you have to replace those hopeful gut feelings with a structured, reliable estimate. This flowchart shows the estimating life cycle: prepare, create, and manage. In prepare, gather records and identify constraints. In create, calculate actual dollars and materials. This forms your baseline, locked in during the manage phase to judge your progress. Setting this initial baseline transforms an abstract, wild guess into a concrete, trackable target. Take a look at this graph, known as the cone of uncertainty. On day one of your bike project, your estimate is naturally going to have a massive range. Maybe you'll spend $300, or maybe $1,000. But as time passes, you refine the details as you go. Once you commit to picking a specific aluminum frame and a particular gear set, the range of your estimate naturally narrows because you have more facts. A wide, intimidating estimate at the very beginning isn't a failure. It is simply the necessary starting point for discovering the truth. To find that truth, you can use opinions from experts or calculations based on hard numbers. If you want the most objective plan possible, you need the math. Let's look at 3 ways to get it. First is the copy-paste method, which works from the top down. If your friend built a custom bike last year that looks exactly like the one you want, you base your estimate on their final price tag. Next is the mathematical rate method. This relies on historical averages. If you know a local bike shop charges $50 an hour for labor and welding takes 4 hours, you multiply those figures to find your cost. Finally, we have the bottom-up method. This is the most accurate approach, but it takes the most time. You have to individually price out every single spoke, cable, and gear, and then tally them all up to reach your final total. You choose between these 3 methods based entirely on how much detailed information your team has at the moment. Even with the right methods, teams often fall into another trap. This happens when someone yells out a random guess early in a meeting, like, "Assembly will take 2 days," and that single number accidentally pulls everyone else's opinion toward it. The easiest way to neutralize that pull is through blind voting. Using a technique called estimation poker, team members determine their estimates privately and reveal them at the exact same time, ensuring everyone thinks for themselves. This is especially vital depending on the type of project you are running. In some projects, you know every detail of a standard bike before you start. But in others, you might be experimenting with a brand new design, like an electric bike with parts that don't exist yet. For those experimental projects, teams use relative estimating. Instead of assigning a rigid hour count to a task, they size it against something they already know. Installing a complex motor might be a t-shirt size large, while adding a bell is a size small. When you're operating in an unknown environment, you have to use relative sizing. It prevents your team from getting stuck on rigid, inaccurate numbers while the design is still evolving. Even the best plans hit friction. Imagine you are building your custom bike and the chain snaps mid-assembly. The replacement is out of stock, your timeline is delayed, and your costs go up. This is why proper planning includes contingency reserves. These are built-in buffers designed specifically to absorb the financial shock of surprises, like broken parts or shipping delays. Because of these surprises, your estimate has to be a living document. As you buy parts, you compare your real receipts against your original baseline. The differences between your plan and reality are called variances. Tracking a variance does not mean your project is failing. These differences provide the signals you need to safely adjust your plan and keep moving forward. When the bike is finally finished, you have one crucial step left. If we look at the flowchart one last time, notice the final arrow pointing outward. You must improve the process for the next project. You do this by comparing your initial baseline against actual costs, diagnosing where best-case thinking influenced your plan. Documenting these differences is highly valuable. Your receipts and timelines from this build become the exact historical facts you will use to make better math-based estimates next time. We started with a chaotic garage and a wildly optimistic guess, but with disciplined preparation, objective techniques, and a commitment to learning from past mistakes, you can overcome that natural human error. Tracking your accuracy and embracing the full life cycle makes project estimation a targeted, data-driven science.